So today we're looking at section 7.4, and actually it's also 7.6. I'm combining the two because 7.6 has only one thing new in it, which is the first thing I want to talk about. And all that one thing is the natural logarithm. Okay? Natural log. So that's the first thing we want to talk about today. If we go back to exponential functions, we dealt with the function y equals e to the x power. Right? We've graphed that one before. By the way, what was e? 2.72 approximately, right? It's that Euler number. So e to the x power. Well, if I find the inverse of that, that's going to give me y equals log base e of x. Well, that right there, log base e, we call the natural log. Okay? Remember that e was called the natural base if you look back in your 7.2 notes for that. Bless you. So therefore, log base e is now the natural logarithm. So the big thing you need to know here, the only thing that really changes for you is that if you see, actually you won't see it written this way, but you need to know that log base e of x is written as ln x. Okay? But we don't call that ln x. Okay? That's not how we say that. Again, math is a language, right? We got to know how to speak the language. So what we say is the natural log of x. All right? That's what ln stands for, is natural log. All right? I don't know why. I think it's the translation from Latin to English. Okay? ln actually stands for natural log. So the way I remembered it when I was your age is I didn't say natural log, I said lateral nog. It made sense to me, okay? Lateral nog, ln. All right? So, but the way you actually say that, ln of x, that is the natural log of x. And what is natural log? It's log base e. Okay? Log base e. By the way, what's the common log? We talked about that a couple days ago. So log base 10. The common log is log base 10. And when we simplify that, we just say log, right? We don't write log base 10 anymore. We just write log. That's the common log. Well, now we have the natural log. And of course, now you guys have enough information to find the front comic on your notes. Not funny at all, but it's a knee slapper, all right? It's a knee slapper. All right. All right, so now that we know what the natural log is, we're just going to move on. It works the same as any other logarithm, okay? There's really nothing different other than what the base is and a little bit of notation. So let's go back to what we're actually going to be dealing with today in depth is our properties of logarithms. Okay, these work for all logarithms of all bases. And our first one is the product property, which says that if we have log base b of m times n, so if we have log base b of two things multiplied together, we can expand that or break it apart into two different logarithms, log base b of m plus log base b of n. Okay, that's the product property. We have one for the quotient as well. If we're dividing, if we have log base b of m divided by n, we can break that into two logarithms as log base b of m minus log base b of n. And our last property is the power property, which says if we have log base b of m raised to the n power, that exponent can be moved out in front and become a coefficient of the logarithm. So log base b of m to the n power is the same thing as n times log base b of m. All right, so there's our three properties. We're got to know how to use those properties. You got to work with those properties forwards and backwards. Okay, forwards and backwards. Now, one thing that I want to show you dealing with these properties, like I said, we had a couple of homework problems that actually I could rewrite using these properties to make them more familiar to us. Okay, to make them more familiar to us. So, if we take a look here at problem 63 and problem 66 from your homework, okay, looking at those two graphs, just just looking at the graphs themselves, can you guys see any similarities or differences in these graphs?
So just little ones.
Say what?
Just little ones. Like,
But the little differences are big things.
yeah.
So what's the difference in these two graphs? Okay, it's off by 10? I don't know. That's what I'm looking for. They have the exact same asymptote. They have the exact same asymptote. Okay, what I'm looking here, if you look at number 63 here, look in that graph. Okay, looking at that graph, we go through 2 points that we were able to graph on our coordinate plane. We go through the point 1, 0, we go through the point 10, 1, right? Well, if we look at the second graph, it looks very similar, except now we go through the point 1, 1, and we go through the point 10, 2. All that's changed is that this graph got shifted up 1. Everybody see that now? Okay, so that means that, and by the way, this first graph says log base 10 of x. How could I rewrite that? Isn't log base 10 the common log? Log x, right? That's the same thing as just saying log x. Okay, so I could rewrite this equation. Rather than saying log of 10x, I should be able to rewrite this as y equals log x, this first equation, but then shift it up 1, right? So plus 1. Right? Because then we just said they're the same graph, except for number 66, it's shifted up 1. Well, that's how we learned a vertical shift, is that at the end there we add a 1. That shifts everything up 1. So what I'm going to show you now is how to rewrite this equation and turn it into this equation using our new properties that we just saw. Okay? That's what we're doing. I don't want you to get confused about, well, now he's showing us graphs and all this kind of... I'm just trying to show you how we could rewrite one equation into the other equation. Okay? All right, so looking at your properties at the top of the page, there is a product property. Okay? When you're multiplying two things together, what can I do? Break them apart using what? Addition. So I have, let me break this up here. So that's on its own here. I'm starting a new one. We have y equals log of 10x, and that's 10 times x, right? So I can break that up and say that that's log 10 plus log x, using that property, the product property from your notes. Everybody okay with that? Everybody see that? All right. Well, now I want to evaluate log 10. Well, there was a property that I had you write down. I had you write down this property in your 7.3 notes. If you flip back a page, you should be able to see that property at the top of your 7.3 notes that says if you have log base b of b to the a power, that gives us a. Right? Yes. Therefore, what does log 10 equal? What does log 10 equal? Evaluate that log. We've done this for 3 days now. Evaluate log 10. What is that? 1. Log 10 is just 1. Why? Because log is log base 10, and the exponent on the 10 is a 1. This is log base 10 of 10 to the first power. So therefore, log 10 equals 1. So that means that equation can be written as log x plus 1. It's the same thing as that, just written in a different form. Okay? That's why these two equations and graphs are similar. That's why the second problem, number 66, is just the same graph but shifted up 1. Because I can rewrite it that way. I can rewrite it so that it looks the way we're used to seeing shift. rather than rewriting it as log 10x, which was kind of confusing to work with. Okay? Get what I'm saying?
Yeah.
All right. Same thing goes for number 67 in your homework from yesterday. Number 67 in your homework actually could have been rewritten. Okay, and let's take a look at this one. If I go through and again break it apart, y equals log base 2 of 4 plus log base 2 of x, that right there is what we're learning today. Expanding, okay? What I'm trying to show you now is that we can rewrite this still, okay? We broke that apart. We still need to simplify if we can. So I want to try to evaluate log base 2 of 4. Well, can I rewrite 4 to be base 2? 2 squared. Log base 2 of 2 squared plus log base 2 of x. What is log base 2 of 2 squared? What is it? 2. Okay, there's a reason why we spent 3 days evaluating logs, folks. Okay, you've got to know how to evaluate logs. And so now I've had that rewritten as log base 2 of x, whoops, plus 2.
So that's just your shift.
Right. And so essentially I've now changed this into a form that we're used to seeing it. Right? So we know that this graph should be just the graph of log base 2 of x, but then shifted up 2. Right? Well, let's find out. Let's just double check that, because we know that we're supposed to have a shift of up 2, and so therefore we graph y equals log base 2 of x, which we first rewrite as 2 to the y power equals x. And now we plot points. Well, I'm not going to plot all the points that we usually do. I'm just going to plot 0, 1, and 2 just to keep our lives easy. All right? So what's 2 to the 0 power? 1. 2 to the first? 2 squared. So that means when I plot those points here, I'm at 1, 0, I'm at 2, 1, and I'm at 4, 2. But then we have the shift. And look what happens on our shift. Each of those points gets shifted up 2 to become that blue curve that I have drawn. So this is the exact same thing as this, but written in a different form. Easier to graph as far as this way? Most definitely. Most definitely. Okay? Which is why we learn these different processes, all right? Yes, sir?
What's the point of having a fraction in the original equation? Is this going to apply to other areas?
As far as what's the point of having this fraction here?
Is this product property going to apply to other areas?
The product property is definitely going to apply to other areas. It's going to help you evaluate different equations when we're solving equations involving logarithms. Yep. So let's go through then and practice these properties. Product property, quotient property, and the power property. Okay? So looking at these, let's actually work on expanding first. Okay, which is basically what I just showed you with those two graphs. So let's go to the bottom of our notes and take a look at example A. We want to expand log of 4x divided by y. Okay, so first thing is first, we want to work with our order of operations. If we knew the order of operations, I would have to first multiply the 4 times the x, then divide by y, right? Well, I'm breaking this apart, so it's kind of like solving. I'm undoing that. So we've got to first undo that division. I've got to break apart the fraction. And so how do I break apart the fraction? Look at the rules at the top of your page. It's called the quotient property. I subtract 2 logs. I've got the log of 4x over y, and so I break that apart as log 4x minus log y. By the way, what's the base of those logs? 10. That's the common log. Okay, but I'm not done. And this is a common mistake, folks. A lot of you look at that and say, okay, I'm done. Okay, you're not done because this is still a multiplication problem. 4 times x. How do I break apart into 2 logs if I'm multiplying?
Oh, no.
We use addition. So this is going to be log 4 plus log x minus log y. Okay? Well, my next question to you is log 4. Is that easy to come up with an answer on that? As far as that a nice whole number answer like 3 or 2? Because how would I evaluate that? I'd say 10 raised to what power equals 4, right? Is that an easy one to do? No, it's not. So we're going to leave that as log 4. If it was an easy one to do, we definitely evaluate that and move on, okay? But it's not easy to work with. It's going to be some crazy nasty fraction for us. So we're just going to leave this as our final answer. All right, we are expanding logarithms. Let's take a look at example B. Log base 9 of x to the 4th power over 729. What do I do first?
Subtract. Or
I use subtraction.
quotient, yeah.
So what do I write?
Log base 9
Of x to the 4th
minus log base 9.
base 9 of 729. Very good, very good. Okay, next, I see an exponent. So what do I do with that? I pull that out in front. It becomes the coefficient of my logarithm. That's the power property. So I have 4 times log base 9 of x minus, now here's another little situation. Log base 9 of 729. Is that an easy one to evaluate? Yes, it is. You can find it on your roots chart. Log base 9 of 729 equals what? Equals 3. Because 9 to the 3rd power equals 729. So there is our answer. Okay? Questions so far? All right, well, let's try another one. Now we are going to start compressing. We're going to rewrite these expressions as a single logarithm, okay, using a single logarithm. So looking at log base 4 of 32 minus log base 4 of 2. I have minus there. So how do I put those together? Division. So I have log base 4 of 32 divided by 2. Okay, but I said if we can simplify, do it. So what's 32 divided by 2? 16. So this is log base 4 of 16. But I also said if it's easy to evaluate, do it.
So it's 2.
Answer is 2. Log base 4 of 16 equals 2. How do we know that? Because 4 to the 2nd power equals 16. Again, that's why we practiced that for the last 3 days. Make sure you're thinking when you're working these. Okay, let's try example B. Nope. Nope, nope, nope. Definitely not. First thing we do is the power property.
Okay.
We have a coefficient out in front. That coefficient becomes our exponent. We have a 5 out in front. That becomes an exponent. So we have log base 2 of x to the 6th plus log base 2 of y to the 5th. Now what? I bring them together using multiplication. This is log base 2 of x to the 6th, y to the 5th. That's my answer. Now, if I wanted to, I could have written that using parentheses. log base 2 of, in parentheses, x to the 6th, y to the 5th, but you wouldn't have to do that.
It's like extreme grouping.
That's exactly what it is. Extreme grouping. Okay? All right, let's do one more example here. One more example. We want to know what is 2 natural log 15 minus natural log 75. Okay, well again, if we're trying to put things together, we can't have the numbers out in front, just like that last example. I can't do it with the 6 and the 5 out in front. I've got to make those exponents first. So what do I do here? I make it 15 to the 2nd power. This 2 goes to the exponent. So I now have the natural log of 15 squared minus the natural log of 75. Now what? Now I can use division to bring it together into one natural log. So the natural log of 15 squared divided by 75. But wait a minute, what is 15 squared? 225. So we got the natural log of 225 divided by 75, and I bet that simplifies. 225 divided by 75 is 3. So 2 natural log 15 minus natural log 75 can be simplified down to the nice little thing of natural log 3. Okay? Questions?